So in preparation for our formative for 1.2 and 1.12, I'm going to go over just a couple of commonly missed homework questions that I noticed as I was going through your work. So for this first part, we're in 1.11, the homework section. If you are in the actual textbook, I'm on page 98. For number 4, I laid out all the work. I showed all the steps for it. Converting units is typically a little difficult for some students, so I wanted to show all of the work so you could follow along. For 7 and 8, it's hard for me grading your work digitally and remotely to know whether you understand it or if you're just copying my answers. So I left 7 and 8 without really any work shown to see if you knew how to do it. And if you just copied the answer, I have to just assume from my standpoint that you don't know how to do it and you're just copying the work. So let's go over number 7 and number 8. Hopefully it helps you out and it'll help you out for your formative. So number 7, one desk requires 84 inches of a type of trim. Find the length of trim needed in inches for 5 desks. Then convert your answer to a potentially more useful unit. So we have 84 inches for just the one desk. Oops. Okay, 84 inches for one desk. We want 5 desks. So I'm going to multiply that by 5. And that gives me the 420 inches. And then from there, 420 inches, I actually have no idea how long 420 inches is. That's a lot. So I'm going to convert that to feet so that I have a little bit clearer picture in my mind of how much trim I'll need. It's a lot easier for most people to visualize feet than it is to visualize inches. So to do this, I'll set up a conversion. So I'm going to change these inches to feet. So to do that, I want the inches to cancel out and be left with feet. So when you multiply, inches on the top cancels with inches on the bottom, and I'll be left with just the feet. So there are 12 inches in one. There's 12 inches in 1 foot. So it'll be 420 divided by 12, and that gives me 35 feet, which is a lot more useful of a unit if I was going to the hardware store instead of trying to figure out I need to buy 420 inches. A lot easier to buy just 35 feet of wood. And then for number 8, if you're driving 70 miles per hour and you look down for 3 seconds, how far have you driven in that time? So we need to convert the miles per hour into something smaller. So let's first convert the hours to seconds because I think that's probably the easier conversion of the two. So 70 miles in 1 hour. And I want to go to seconds because, well, they're telling me I need to go to seconds for 3 seconds. So there are, in 1 hour, there's 60 minutes. And then when I do that, hours will cancel and I'll be left with miles per minute, but I don't want miles per minute. I want miles per second because that's the unit we're going to be using. So then I'll do one more conversion. In 1 minute, there are 60 seconds. And then once I do that, minutes will cancel, and I'll be left with miles and seconds. So from there, let me type that into my calculator because I definitely can't do that in my head. So we'll go 70 divided by 60 times 60. So we are going 0.0194, and then my units I'll tack on. My units are miles per second. Okay, because that's what was left. Miles per second, I have those boxed. Okay, so I'm going 0.0194 miles per second. I have no idea how long 0.0194 miles is. So let's convert those miles to feet for something a little bit more realistic for us. So I'll make this into, I'll just go down here, 0.0194 miles per second. I want to make those miles into feet. Okay, because then when I do that, miles will cancel and I'll be left with feet and seconds. So from here, there are 5,280 feet in 1 mile. So then I'll go back to Desmos and I'll go 0.0194 times 5,280, and I'm left with 102.432. And what are my units? Feet per second. Okay, so every second that you're looking down, you're going 102 feet. Well, the original question was asking us how far have we driven if we look down for 3 seconds. So I'm actually going to multiply this by 3 for feet per 3 seconds. So then I'll just tag on times 3 at the end. And I have 307 feet in 3 seconds. Okay. In the answer key, it says 308 feet. It was probably due to the fact that I rounded this 0.0194. That's probably where that 1 foot discrepancy came in. Hopefully those two helped you out. I'm going to make another video for 1.12. Okay, so we're on 1.12 now. If you're working in the actual textbook, I'm on page 109% change. I didn't notice too many issues with the percent change, so long as you remember the formula that was going on. Number 7 was the one that I saw some of you just copying down the answer for part A and B. I didn't really see any work, so again, just assuming maybe you don't know how to do it, and hopefully the video helps you out a little bit. So you have an investment of $1,000 in a stock. Consider using the 2-step method to find percent change when answering the problems, since it might be more illuminating. In 1 year, the stock loses 10% of its value. What is it worth now? Okay, so my original amount invested is $1,000, and we lose 10% of its value. So I'm going to multiply by 0.9. Okay, why did I multiply by 0.9? Well, because we're losing, so it's going to be 1 minus the 10%. And I can't go minus 10%. I need to write that 10% as a decimal. So I'll go minus 0.1. So 1 is the original value, which was the $1,000, minus the 10%, which is represented as 0.1. So that's how I got the 0.9. So now I'll do 1,000 times 0.9, and we get $900. So if our $1,000 investment lost 10% of its value, it will be worth $900. Now in part B, the following year, we still have the $900 invested. The following year, the stock's value is going to increase by 10% over its previous ending value. What is it worth now? So my starting value was $900. Oops. $900. And it increased value by 10%. So 10% increase is going to be 1 plus 0.1. 0.1 just as 10%, and we're adding because we're increasing. So this will leave me multiplying by 1.1, and that will give me $990 as the value of the stock now after the 10% loss and the 10% increase. So part C, I just left the answer from the answer because I didn't feel like rewriting it all. But is it true that a 10% loss followed by a 10% gain has no net effect? Why or why not? So if you were just looking at this and I had asked you without doing any math, do you think a 10% loss and a 10% gain would they just like cancel each other out? In the long run, would I be back at my $1,000? Willing to bet some of you would say yes, that they are going to have no effect. But since we just did the math, it's not true. Those percents do not cancel each other out. The amount that you're applying the percent gain and the percent loss to are not the same. So my starting value for this first one was $1,000, and then I applied a percent change. In the second one, my starting value was $900, and I applied a percent change. So since we applied the percent gain and loss to different numbers, it's not going to cancel each other out.